Hey everyone, the question that I'll be solving now is closest cities that came in Educational Code Forces round 161 rated for Div 2. In this question, you will be given n cities and the IS city is point AI. The coordinates of the cities are given in ascending order. Like the distance of city 2 will be greater than the distance of city 1, like so on and so forth. And the distance between two cities x and y is the absolute difference between those cities positions. Let's define the closest city for j is for each city I there would be some closest city j, and if it would be closest if the distance of city I and j is lesser than the distance of any city k from I. If it is the smallest distance between those cities, so each city would have some closest city, and if the city I want to travel to its closest city, then the cost for that would be 1. If he if I'm standing at y city and if I wanted to go some x city, then I need to pay the difference between their positions, like the absolute difference. If I am standing at X and I want to go to Y, then AX minus AY, the absolute difference, that much I need to pay. If the X is not the closest city. If it is, then I need to pay only one coin. So there is two conditions. If you are standing at X, then you'll be given queries. Then what is the minimum cost to travel from the city X to Y? So you can travel from X to Y, like from the front to backward or from backward to front. So there are two conditions, like X and Y can be anything. Like either you could be given that calculate this cost to travel from the city Y to X. So you need to go from backward to front. So there are two conditions. So we could have a array because for each query we cannot traverse to the array again and again. That would be a time limit exceed solution. So we could pre-calculate those. Let's have a two array. So one could store the sum to go from front to backward. Let's say it's to go to samne and one to go to piche. So if I want to go, let's say for going for city 0, it would be 0. Like for the starting city from the front, it's 0. Now if I want to go to city 1, now if I'll be standing at city 1, so I will be checking that the I minus 1th position is that city has the nearest neighbor as me. If it is, then I could add the summation you have plus 1. But if it is not, then I'll be adding the difference between us. That would be the minimum distance to go to city 1 from the front, and so on and so forth. Like for each city I'll be checking, is the previous city for the previous city, am I the closest or not? If it is, then I'll be adding 1 to the previous sum. That would be the minimum sum to reach that city. But if it is not, then I'll be adding the distance between those cities. Now I'll be doing same from the backward. Like if I'm standing at the last city, then it would be 0. Now for each city I'll be checking that for that previous city, who's the neighbor for that previous city, what it is. If that city is the current one, then I'll be adding 1 to that sum, else I would be adding that distance. So this is from backward to front. So if I have this two, then I'll be checking for each. Like if I want to go from X to Y, it's from the front. Like I'm going from the backward to front, like I'm going samne. So I'll be calculating that difference only, like going to city 2 minus that city x, because I could assume that I'm standing at city x, so the distance to reach the city x would be 0, assuming. So I'll be removing that distance I'll be removing that cost to reach city X from Y. So the difference, and if I want to go from Y to X, then I'll be using that the this second array, and I'll be reducing that X minus Y, the destination minus the source. Let me show the code and it will be more clear. What I did is I've taken just input and initialized with 0. Now for the last city, there is only one neighbor, that is to the left. That's why I'm using -1. And for the 0th city, the neighbor would be at the right. That's why I'm using 1 for the right and -1 for the left, and 0 for both. Then I'm calculating the distance for each and every city. Like I know the 0th city's neighbor and the last city's neighbor, so I'm going from 1 to in -2. And then for I'm calculating the distance of the current city from the front as well as from the backward. So if both the distance are 0, it means both are my neighbor. If the d1 is lesser, it means I have a neighbor at the left. If the d2 is lesser, it means I have a neighbor at the right. Now I'll be calculating that the array pch and sm is for the sun and pch for the peach. I'm going at the peach direction. Now n -2 to 0, I'm going from the backward. Now if the ngh of I plus 1, what it is, uh, like for this element, what is its neighbor? Is it at the right or it is at the left? That's what I'm checking. If it is not at the right, it means it is 0 or -1. That it If it is not at the right, then it could be at left or both. That's why I'm doing 1, that I am neighbor of that I plus 1 city. If it is -1, it means at the left. It means if it is not right, then I'm doing a pch of ai, the distance. If this city's neighbor is not this particular city, then I need to calculate the distance between these two cities. That's the only way. So I have calculated those, and that's a prefix sum. And same, if I'm going to the front direction, so if it is not -1, then I am not its neighbor, the previous elements. So it is not -1, then it means I'm its neighbor. It could be 0 or 1, so I'm its neighbor. That's why I'm doing plus plus, and I'm just calculating the difference if I'm not a neighbor. And then I'm taking xy, the city I need to go to up to y from x, and I'm reducing 1 because to make a zero based indexing. Then if it is greater than x, then I need to go to like in the samni direction. So sm of y minus sm of x. If I need to go at the pch direction, like then pch of y, that the destination minus the source, same thing. So I think it would be helpful. Thank you for watching.